So today I'm going to be showing you how to derive the three formulas of motion. So we'll start with the first one. In the first one, we need to find the acceleration. Now the acceleration here is equal to EF divided by dF. Let me just write that down. Acceleration is equal to EF divided by dF. Now what is EF? EF is equal to EC minus FC. EC minus FC. Now here EC is the final velocity and FC is the initial velocity because the graph is starting from the point D. So dB will be the initial velocity, which is also equal to FC. So FC is the initial velocity and EC is the final velocity. So we can say EF is equal to V minus U. V is the representation for final velocity and U is the representation for initial velocity. Now we have to find dF. dF is nothing but BC, which is also the time. So we can write dF as the time. So what we have here is A is equal to V minus U, as we found out EF was V minus U, divided by dF. Now dF was nothing but BC, which is also T, which is the time. So here we have it, the formula. A is equal to V minus U by T. So let's start with the second equation. In the second equation, we have to find the distance, which is always the area of the graph. Here, which is the trapezium BDEC. Now to find the area of this trapezium, we need to divide it into two shapes. One triangle DEF and the other a rectangle BDFC. Now, to find the area of the first we have to find the area of both the shapes and then add them together. To find the area of the rectangle, we need to multiply dB to BC. Why do we need to do that? Because the formula is length into breadth. Now, from the previous equation, when we tried to derive the first equation, we found out that dB is equal to U and BC is equal to T. So the area for the rectangle will be equal to UT. Now for the triangle, the formula is half into base into height. Now the base here is dF, which is again time, and the height here is EF. Now in the previous equation, EF we found out was V minus U. And now we can make V minus U AT from the first equation. We'll just put the T to the other side. So it'll be multiplied with A. So it'll be AT is equal to V minus U. So we can write the area of the triangle to be half into BC, which is T, and multiplied by EF, which is AT, as we found out, AT. Now we can simplify this further to make it half into AT square. Now when we add both of them, we get UT plus half multiplied by AT square. So the distance, which is written as S, is equal to UT plus half into AT square. And thus we found out the second equation. We derived it. Let's move on to the third equation. In the third equation, we find out the distance as well, but this time it's from a different formula. As you know, we'll have to find the area of the graph, but we'll find it from the formula of a trapezium. Now the formula of a trapezium is half into the sum of its parallel sides multiplied by the height. Now the sum of its parallel sides are dB plus EC, which is also equal to dB is the initial velocity and EC is the final velocity. So it's equal to U plus V. And the height here is time, which is dF, which is time. So we can write it as the area would be half multiplied by V plus U multiplied by T. Now here we can substitute the T by here by V minus U divided by A, because from the first equation we can just exchange the A and T. So the T will go to the other side and the A will come down. So T will be equal to V minus U divided by A. So that will give us half multiplied by V plus U and V minus U divided by A. Now V plus U multiplied by V minus U is V square minus U square. So we have the formula here. The distance, which is S, is equal to V square minus U square, because A plus B into A minus B is an identity, which is equal to A square minus B square. And we divide this by 2A. So this is how we derive the third identity. If the video helped you, please subscribe. It really helps me a lot. Thanks.